Greetings, class. I thought I might go ahead and go through an example for you from Chapter 9, Section 1. This is actually Example 1 on page 471 of your eText, comparing the GDP in trillions of dollars, and this is going to be our X value or independent variable, and these are in trillions. And then this is going to be the corresponding CO2 emissions in millions of metric tons, and this is going to be our Y value. The first thing that they ask you to do, for example 1, is to construct a scatter plot. To do that, we would go Graph, scroll down to Scatter Plot. Our X variable is the GDP, and our Y variable is CO2. I'm going to scroll down. All we want to display are the points, and it's a filled circle. Point size is 2, so we should be able to see the circles well. And I'm just going to go ahead and click Compute, and you see a scatter plot that should look very similar to the one you see on page 471 of your eText. Now, if you look at this scatter plot, it does seem that as the GDP increases, so do the CO2 emissions. And so it does look like it might be a positive linear correlation. It's somewhere between 0 and 1, but we need to figure out what that correlation coefficient is for this particular type of data. So in order to find that value of R, the correlation coefficient, we go to Stat, Summary Stats, and Correlation. Now you need to select both columns, the GDP, and then I'm going to hold my Control key down while I click CO2 so that you see that both of those columns have been selected. And that's all we have to do. We just click Compute, and then you see that the option window says the correlation between GDP and CO2 is 0.9115. Now that's 0.9. That's pretty close to 1, which is the highest correlation. That's like that's a perfect correlation is 1. So this is a strong correlation between GDP and CO2 emissions from those countries. Greetings. I thought that it might be easier to type out some information once we found our correlation coefficient. So once you've calculated your value of R, which in this case was 0.912 to 3 decimal places, then we need to determine if the population correlation coefficient rho, looks like a little p, but that's a rho, Greek letter rho, is significant. So we want to determine if the population correlation coefficient is significant. Well, there are actually 3 different ways that the text can show you to do this. So the first way is to compare the absolute value of R, and I've shown that as a mathematical expression, the 2 bars with the R in it, that's the absolute value of R, to critical values for the Pearson correlation coefficient, that's our value of R, for a given level of significance, and I'm just going to use alpha equals 0.05 for our example from the text, which was relating GDP and CO2 emissions. So our value of R, 0.912, rounded to the nearest thousandth. You will go to Table 11 on page A26 of your eText and use the column labeled alpha equals 0.05 and in the number of pairs in data. If you'll remember from our StatCrunch file, there were only 10 pairs of data. So we will use n equal 10. So if I've just copied a small piece of that table. So n is 10. And the column we want to look at is for our level of significance to be 0.05. And so the critical value for our correlation coefficient is 0.632. So if the absolute value of our value for R from StatCrunch is greater than the critical value, then R is significant. So notice that our calculated value of R, 0.912, is greater than 0.632. That's the critical value from the table. So the correlation is significant. So the population correlation row is significant. So that's one way to do it, using the table in the back of your text. Another way to do it is to do a t-test. So if we do hypothesis testing using the t-test, typically the null hypothesis is that rho is 0, which means there is absolutely no correlation at all. And H sub A says it's not 0, which means there is a correlation. It could be positive, it could be negative, but it's certainly not 0. So the first thing we would need to do would be to use the t-calculator to find critical values for t sub 0. Since H sub A uses the not equal symbol, we do a two-tailed t-calculator. But remember, when we do this, we use 1 minus alpha for the area so that the rejection regions are the two tail areas on the left and the right of the red area. And again, since there are 10 pairs of data, we use, for degrees of freedom, 10 minus 2 equal 8. Now, I've done this in StatCrunch. I'll go ahead and repeat that so you can see it. Here's the results, but I'll go ahead and go back through how I figured that. I went to Stat, Calculators, T. I clicked Between because this was a two-tailed. H sub A had a not equal. Our degrees of freedom is 8. It was 10 minus 2. And instead of alpha, we use 1 minus alpha. Alpha was 5%, so we need 95% or 0.95. Click Compute, and you will see that our critical values are negative 2.306 and positive 2.306. So that our rejection region is over here to the right, and our other rejection region is to the left. Now this only is necessary when we use between, and that between goes with H sub A being not equal. It's very important that you realize that H sub A being not equal forces us to use 1 minus alpha for the area. So let's scroll down, and there's the results of the t-test. So the critical values are t sub 0 equal plus or minus 2.306. And our rejection regions would be if our test statistic was less than negative 2.306. That's this area over here. Anything less than 2.306, negative 306. And then t greater than 2.306. So that would be this area on the right. T greater than 2.306. So we've got our critical values. Oh, I'm so sorry. That went way up there. So we've got our critical values and our rejection region. Now, unfortunately, we're unable at this time to have StatCrunch calculate the t-stat value, or a value for t, the test statistic. So you'll have to do the calculation by hand. The t-test statistic is R over the standard deviation for the correlation coefficient, which is the square root of 1 minus R squared over N minus 2. So I've put the numbers in here. Our R value was 0.912, and in the denominator I have the square root of 1 minus 0.912 squared, all divided by 10 minus 2, or 8, and then I took the square root of that. And I ended up with 0.912 over 0.145, which equaled 6.289. So that's our standardized test statistic. Notice that our t-value is greater than 2.306. That's the critical value that tells us that this 6.289 would be in the rejection region. So we would reject H sub O. We have sufficient evidence at the 5% level of significance to conclude that there is a significant linear correlation between GDP and CO2 emissions. Now that's the second way. Now the third way, if they don't ask you for a critical value, or they don't ask you for the value from the table 11 in the back of your book, the fastest way is when you did this original test. I'm going to pull that back up in StatCrunch. When we did the original correlation between GDP and CO2 to get our 0.912 to 3 decimal places, that if I go back and do this over, so I will, I'll just go back, stat summary stats, correlation. I selected both columns. I hit the control key and the CO2, so both of them are selected. And then, do you see this two-sided p-value? Just click that. And what's going to happen is, do you see that you get a window very similar to the first one we got with the 0.91159,239? But then you get this other little value here, 0.002. That is a p-value. So I'm just going to write that down. That is our p-value. And you remember that in the past, when we've had p-values, and I'm just going to copy and paste this, that if our p-value is less than alpha, if our p-value is less than alpha, then we can reject H sub O. Well, our p-value here was 0.0002, and our alpha value was 0.05. So it's easy to see that our p-value is indeed less than our alpha, so we reject H sub O. So all three methods that we've looked at, I'm just going to go back rather quickly and pick that back up from the very beginning. The first method was to use table 11 and compare our R value that we got to the critical value that you get from the table. And if R is greater than that critical value, you reject. The second one is a lot more complicated. We have to calculate a test statistic and compare it to the rejection region. Is it in the rejection region? And yes, it is. And then the last one was from StatCrunch itself. I'm so sorry. Somehow or another I got off of the page. That gives you a p-value. All you need to do is be sure when you click the options that you check the box that says two-sided p-value. I hope this helps you make your way through section 1 of chapter 9.